Hi, let's solve lead code question rotting oranges. Here you're given an m cross n grid where each cell have three kind of values. So there's a grid given, and each cell in the grid can have three kinds of values. One is zero. If the cell is zero, then the cell is empty. If it is one, then there's a fresh orange. If it is zero, then it's a rotten orange. So every minute, any orange that is four directionally adjacent to a rotten orange becomes rotten. So for every minute, uh, for each minute, it takes 1 minute for a rotten orange to rot the oranges, fresh oranges that are four directionally adjacent. That means either sides, like up or down or either sides. Uh, Return the minimum number of minutes that must elapse until no cell has a fresh orange. If it is not possible, then return -1. Let's check the example. Uh, Here, the matrix is like this. This is a rotten orange. So this is minute zero. In 1 minute, it will rot the oranges that are adjacent to it. So these two will get rotten. In second minute, these two will get rotten. And in the third minute, this one will get rotten. And fourth minute, this one will get rotten. So finally, the whole grid is getting rotten except for the empty cells. So we return 4. In the next test case, it is -1 because the grid is in such a way that, like for example, it is 2, 1, 1 and 0, 1, 1 and 1, 0, 1. So here, this is the rotten orange. So in first minute, it will rot this one and it will rot this one and it will become 2. And in the second minute, it will rot this and it will rot this. In the third minute, it will rot this. And fourth minute, it will rot this. But since there are no adjacent cells for this one, which are rotten, so this can never, it is impossible to rot this orange. Uh, Hence, it is impossible and we return -1. And in this one, it is 0 because there are no fresh oranges to rot. We can see that this is a graph question and we can solve it using BFS. And let's start coding. Firstly, I'll check for all the rotten oranges and uh, I'll mark them and push them into the queue as starting point for BFS and then explore the other adjacent oranges. If they're fresh, then I'll rot them and so on. Let's start coding. First, taking the size of the grid, 0, right? And then I'm initializing the queue and I'm keeping a count of fresh oranges so first I'll count all the fresh oranges. So in this example, there are 1, 2, 3, 4, 5, 6, 6 fresh oranges. And then while I'm doing the BFS, I'll keep rotting them, right? So I'll decrement the fresh count, the count of fresh oranges. And after the whole BFS, if the fresh oranges count is zero, like if the all the then that means all the oranges are rotten, all the fresh oranges are rotten. If it is not zero in this, which is in this case, then we'll have to written -1. So let's initializing the visited array, a list. Here I'm uh, traversing through the whole grid and checking for the fresh oranges and the rotten ones. And if they're rotten, then I'm pushing it into the queue and marking them as visited. If grid of I comma j is equal to 2, then q dot append I comma j comma 0. Here 0 is the time, since it's the 0th minute. So initial starting points, we write them as 0. Then visited of I comma j is equal to 2. Elif grid of I comma j, if is equals to 1, then that means it's a fresh orange. Then we increment the fresh count. So here we got all the starting nodes and then the count of the fresh oranges. Now let's perform the BFS. To make the BFS traversal easier in the 4 directions, let's take dimension list in row and column. And d call is equals to 0, comma 1. Next, let's take a variable time which is equals to 0. Now, let's check the queue while the length of queue is greater than 0, while the queue is not empty. Row, column, and time. So we're checking the row, column, and time of left. Now time, we take it as max of t comma time. Next, for I in range 4. So now for this particular cell, we are exploring the 4 directions in the grid. New row will be row plus t row of I, and new call will be C plus T call of I. Next, after we got the new row and new column, we must check the conditions. One is if new row and new column are between 0 and n and m, and the other one is if the visited of like if it is visited or not, we'll check it in the visited list. And if it is a fresh orange, only if it is a fresh orange, we are making it as a rotten orange. In other cases, if the value of the grid, if that cell value is 0, then we should not be rotting the orange, right? So if equals to 0 and less than visitor of n row n call, if the visitor is not equal to 2, that means if it is not visited, and if the grid of new row and new call is equals to 1, is equals to 1, then we write, we push it into the queue, append, comma, t plus 1. So the t is the time of the given cell, and in the next adjacent cell, it will be in the next t plus 1 minute, right? So we append t plus 1. Next, we mark it as visited. And here we decrement the fresh orange count. So the BFS code is done. Now here we check if the fresh count is equal to 0. If it is not equal to 0, then we have to just simply return -1 because some or like one of the like fresh oranges are present in the grid. Then we simply return -1, then return type. Right. Let's run. So, oh, okay. So, it's running fine. Thank you for watching.